Our first problem is working out the area of a regular hexagon. To do this, we're going to split it into 6 equilateral triangles. You might want to consider how we know these triangles are equilateral by looking at angles inside a polygon. So now we have our hexagon in 6 equilateral triangles, so they're all 4 centimeters. And we need to work out one triangle's area so that we can multiply it by 6 to get the total area of our hexagon. To do that, we are going to split this triangle down the middle and find a right angle triangle inside. So this right angle triangle is going to have a base of 2 and a hypotenuse of 4. We can use Pythagoras to figure out the height. We need the height because the area of a triangle is base times height divided by 2. So my height x must be the square root of 4 squared minus 2 squared, using Pythagoras. So that means x is the square root of 12. 12 I can rewrite as 4 times 3. The reason I want to do that is because by finding a square number in here, it means I can simplify that third. So the square root of 4 is 2, so this is 2 root 3. So now the area of one triangle must be 2 root 3 times 4 divided by 2. So that is my height, 2 root 3, times 4, my base, divided by 2. And then I can do some lovely cancelling. So we can make one triangle 4 root 3. So if one triangle is 4 root 3, my total area must be 6 of them. So it's 6 times 4 root 3, also known as 24 root 3. Done. Our next problem is finding out the area of this regular octagon with sides of 4 centimeters. To do that, we're going to put it inside of a square. Now my octagon is inside of a square, I can see that it leaves these right angled triangles in each of the corners. So to work out the area, what we're going to do is figure out the area of the square and take away 4 of these right angled triangles. My problem is that I don't know this pesky x in the corner here. I don't know what length that is. So what we can do is use some Pythagoras again. So if we have a look at this triangle over here, I know that by Pythagoras' theorem that x squared plus x squared should equal 4 squared. So I know 2x squared is 16, so that means x squared is 8, so x is the square root of 8, which I can simplify to 2 root 2. Now that I've gotten that far, we need to work out the area of the whole square and take away 4 lots of the area of this triangle. So the whole square is a little bit tricky because this full side down here is going to be 2 of my x's and this 4. So the area of one side of my square is going to be 4 plus 2 lots of 2 root 2, so 4 root 2. And I'm going to have to square the whole thing to get the area. So this is like multiplying out a quadratic. I can say that 4 times 4 is 16. Then I've got 4 times 4 root 2, so that's 16 root 2, but I'm going to do the same again, so that's actually 32 root 2. Then I need to square this end part, so 4 times 4 is 16, root 2 times root 2 is 2, so 2 lots of 16 is 32. And I'm not going to simplify it for reasons you'll see in a minute. So now I need 4 lots of my right angled triangle, so I need 4 lots of base times height divided by 2, so that is 2 root 2 times 2 root 2 divided by 2, and I can do some cancelling here, so let's get rid of that 2 and get rid of that 2. Then I'm going to have root 2 times root 2, well that's 2, then 2 times 2 is 4, 4 times 4 is 16. So the reason I didn't cancel this is that if I take away my square and my right angled triangles to get my total area, I can see this 16 and this 16 will cancel away, so it just makes it a little easier. 32 root 2 plus 32, and I'm going to go as far as to factorize it because it looks nicer. Done.